Hello Year 7s, it's Miss Shafiq speaking here. Welcome back to your third lesson on the space topic. Today what we're going to be learning about is the solar system. Now I know a lot of you are very interested to learn about the solar system. I know you already know the different planets that there are. Used to be 9, now there are 8. Pluto is no longer considered a planet. It is of course a dwarf planet. So what we're going to do is we're going to go through the different planets of the solar system. We're going to look at their orbits, the shape of their orbits as they rotate or orbit around the sun. And we're also going to look at how they came into existence, which is going to be very interesting. So you're going to have to keep your thinking caps on, concentrate really hard because you've got quite a tricky challenge to do at the end of this lesson. I just thought we'll start with this picture in front of you. You can see it's a diagram of the solar system, and you've got what looks like an absolutely tiny planet of the Earth. And it is very small, relatively speaking. I know it seems like it's very big to us on here, but as we look at it from outside the solar system or from where Jupiter is, you can see in front of you here, it does look absolutely tiny, doesn't it? So anyway, let's get started. Our lesson. You're going to need your science book or piece of paper if you run out of space, and you're going to need your stationary equipment including pen, pencil, rubber ruler, highlighter and so forth. Before we get started on the lesson, I just want to show you some fantastic pictures that we had based on the practical that I set for you yesterday. I know we went through the phases of the moon yesterday, and I asked you to do the same practical that you saw in the video, but using a lamp or torch and a round fruit on the end of a fork. And we had this absolutely fantastic collection of pictures from one person showing us the different shadows that they got on that fruit, and you can really clearly see as well the different phases. So you can see in this top right hand corner there's the crescent, you can see the first quarter, here you can see the last quarter, and here's the crescent again on the other side before we get back to the new moon. So this is an absolutely fantastic demonstration, so thank you very much for that one. Right, now before we get started with the rest of the lesson, let's do a do now task. You have got 5 questions here and 5 minutes to complete these questions. Try as many of them as you can. Some of them are from previous lessons, some of them are from a very long time ago. So let's see if you can remember. Press pause, and when you are ready, press play, and we'll go through the answers together. Okay, question number 1. Name the phases of the moon. You've got 3 pictures here. If you did what I did when I first started recording this, I ended up writing all 8 phases of the moon before I realized I had to just name the phases in the 3 pictures here. So let's have a look at the first one. The first one, we have got the full moon. It's really pretty, the full moon, doesn't it, when it's out? The second one, we can only see some of the moon. We can see the left side, the right side is shaded, so that is the last quarter. We've got the final picture, which is the crescent moon. So well done for those ones. Question number 2, what does luminous mean? If you remember, we used the example of the sun in the last lesson. We said that the sun is a luminous object, and luminous means it emits its own light. It gives out its own light. Like the sun gives out its own light, a light bulb gives out its own light as well. Question number 3, what are the units for force? There are 2 ways that you could have written this. You could have written the whole word for me, which is newtons, or you could have just written a capital N for short. Make sure it's capital though and not lowercase. Right, question number 4. Draw the diagram for a beaker. So draw the diagram for a beaker. Very straightforward. You didn't have to draw a 3D version, you just needed to draw something that looks similar to this. It could probably be a lot neater than the one that I've drawn on the page, but something like that. And then question number 5, name the male reproductive cell. So we said that the female one was the egg cell, didn't we? And the male one is known as the sperm cell. So really well done if you got all those ones correct. If you need to make any corrections, please do. And when you are ready, go on to the next slide. So your lesson objectives for today, we're going to state the names of the planets in the solar system. We're going to state the difference between the geocentric and heliocentric views of the solar system. We're going to describe the elliptical shape of the orbits. We'll see what that means later on. And we're going to use information from the lesson to make a concept map, which we'll also see what that means. Okay, before we start, here's another little fun fact for you. In ancient Greek times, the ancient Greeks used to believe in a geocentric model of the universe, which is a model where they believed Earth was at the center of the whole universe, and all the different planets, stars, the sun, the moon, everything orbited the Earth. Obviously, we now know that the heliocentric model is correct, that the sun is the center of the solar system, not necessarily the center of the universe, but it is the center of the solar system. And it was Nicolaus Copernicus who came up with the theory that actually it is the sun at the center, and then that's when we had the Copernican revolution. Very interesting history. But yes, ancient Greeks used to believe that geocentric theory was correct, but obviously we now know that the heliocentric one is. So, going to have a look at how the solar system was formed. So I'm going to give you some explanations, and I have just given some brief notes for you, which I would like for you to copy down as we go through these slides. Okay, so some of the information might seem a little bit confusing at first. There might be a lot of words that you might be unfamiliar with, but hopefully going through these slides together, it will become a lot more clear what it means. So in front of you, what you should be able to see in these regions where you can kind of see clouds, those are areas where there is a lot of dust, there's a lot of hydrogen, and there's a lot of gas. Okay, so in order for a solar system to be formed, throughout the galaxy, what's going to happen is that these large clouds of dust and gas are going to come together over millions and millions of years, and they're going to be pulled together by gravity. Okay. So you've got large clouds of gas. In some of the elements in that are hydrogen. Hydrogen is the most common element that exists in the whole universe. So you've got large clouds of gas containing lots and lots and lots of hydrogen, and that's going to come together over millions of years, and it's going to be pulled together by gravity. That's the first one. Once you've copied that down, go on to the next slide for me. So what's going to happen to that large cloud of gas containing hydrogen and dust that's just come together? That is going to come together, the hydrogen cloud, so that's number one here. You can see number one, hydrogen clouds and dust, they collapse together, pull together by gravity. As they get closer and closer, this is number two, it's going to get hotter and hotter and hotter. So the center of that in particular is going to get really, really hot. And after that, what's going to happen? Things start spinning. Okay, you're going to have, I don't know why I've just written 4 there, it should be 3. You're going to have a lot of that, a large part of that cloud is going to start spinning, and within that, so we've got number 4 here as well, that hydrogen that was in that cloud is going to start to heat up, and it's going to start to fuse together to make helium. Now, what do we mean by fusing together? So if I take a hydrogen, I'm just going to write H for hydrogen, and I take another hydrogen, so another H, so H and H, they are going to join together and they are going to make helium. So I'm just going to write He for helium. Okay, so what's happened so far? The hydrogen clouds and the dust have collapsed together. Gravity has brought them closer together. The center is going to get hotter and hotter and hotter. That is going to start spinning then. It's going to get a lot hotter, and it gets to a point where it's so hot that the hydrogen inside of it is going to join together. It's going to fuse and it's going to make helium. Now, by doing that, by the hydrogens fusing together and making helium, it's going to release a lot of heat and light energy. So energy is released, and that is what leads to the formation of the sun. Okay, so the sun really is just a bundle of hydrogen that's joining together and releasing energy. And if you remember from the last topic, we said that the ultimate energy source for a lot of the things that we have on Earth is the sun. Remember the video that we saw with the guy eating crisps and it made everybody hungry? Yeah. So the ultimate energy source is the sun, and the sun releases that energy, and that energy comes as a result of all those hydrogens joining together to make helium. So if I give you a little bit of energy on the next slide about the sun, we say that nuclear fusion is happening. And all that nuclear fusion is when hydrogen atoms combine together to make helium. And by doing that, they release so much energy, they release so much heat energy, they release so much light energy. That's what we see on the Earth, and that's what we feel on the Earth as well, that warmth from the sun. Okay, so just take a minute or two, however long you need, to copy down the information, and when you're ready, let's go on to the next slide. Okay, so let's start off with some information about the smaller planets. I don't know if you remember what the names are of the smaller planets. These ones are not actually in order. So we've got Mars. This one, that is not Mars. We've got Mercury. We've got Mars. We've got Earth. And this one is Venus. Okay, so we've got 4 of the smaller planets. These ones are the ones that are closest to the sun. They're not necessarily in order though, so that will come in a little while. So these smaller planets are known as the rocky planets. So they mostly consist of solid rocks, which is why obviously they're known as the rocky planets. And because they're quite close to the sun, these are a lot hotter. So Mercury is very hot, Venus is very hot, Earth is what it is. Earth is like Goldilocks. So the reason why I've written Earth is like Goldilocks there is because it's the absolutely perfect temperature for water to exist as a solid, as a liquid, and a gas. So you can see ice at the bottom, so that's where water is a solid. You can see the oceans, that's where water is a liquid. And you can see these cloud formations as well, which is the only way you can have that is where you have water vapor, so water that turns into a gas and then goes together to make those clouds. So Earth is like Goldilocks, and the reason why it's like Goldilocks is because it's not too hot. It's not too hot. If it was closer to the sun, it would be so hot that all the water would just boil away and evaporate. We wouldn't have any left in the oceans. And then if the Earth was further away from the sun, it would be too cold. But we know that it's not too cold either. If it was too cold, everything would just permanently freeze over. So that's why Earth is like Goldilocks. It's not too hot, it's not too cold, it's just perfect. And I just want to give you a little bit of information about Mars. Now, the colour of Mars is red is because it's got a lot of iron in its rock formations, and it's absolutely amazing. You can see NASA's video now of the probe that landed on the surface of Mars. It looks kind of like a desert, but it's very, very cool to know that we have now got a probe on the surface of Mars. So I have put a link in class charts for you if you want to have a look at that video. Okay, so now let's go on to the larger planets. Now the larger planets are gassy planets, gas planets. I don't know why I've written gassy. And they are a lot larger than the smaller planets that we just saw on the other side. In fact, if Jupiter were any bigger, it might have become another sun in our solar system. So that's how big Jupiter is. And a lot of the planets have got rings around them, so we can see Saturn's rings with large binoculars or small telescope, but the other planets also have rings around them, but maybe not big enough for us to see. And what happens with those rings are formed of dust particles and rocks, and over time those dust particles and rocks, they come together and they're pulled together by gravity and they make moons. So we know that Saturn has a lot of moons, and we know it's got more moons than we thought it did because we sent a probe up to see. And what's happened is there are a lot more moons than we thought because a lot of this dust from Saturn's rings is coming together to form those moons. Okay, so the planets that you've got here are Jupiter, so let's write this here, Jupiter. We've got Saturn with its rings, and you've got Uranus, and finally we've got Neptune on the end. And we know that Pluto is no longer considered a planet, so we only have 8 planets in our solar system. Pluto is a dwarf planet, bless it. Alright, so what I would like for you to do now, we've gone through the information as to how the solar system was made. I just want you to copy down the names of the planets that you can see in front of you. Write down the planets in order, starting with the one that's closest to the Sun first, and then tell me what you notice about this picture. What can you see in the diagram that doesn't belong there? So I want you to write the answer down in your book as well, and I will check it when I go through your answers. Okay, so press pause, and when you are ready to continue, we'll go on to the next slide. Right, so what is a year? How do we get a year then? So the reason why we're going through this is because we obviously said that we've got 8 planets in the solar system. The Sun is at the center of them, and all of the planets orbit the Sun. So they orbit the Sun, meaning they go around the Sun. And you can see from this really funny picture here, actually, where you've got the Earth going around the Sun, asking, "How's my time?" And the Sun says, "It took you 365 days again." And the Earth says, "Sweet, at least I keep beating Mars." So a year is the time taken for a planet to orbit the Sun once. So what I would like for you to do is take a minute to answer the following questions. Which planet in our solar system has the shortest year, and which one has the longest year? Okay, so just take a few seconds to write your answers down, just copy the information, and then we'll go through the answers. Okay, so the planet with the shortest year is the one that's closest to the Sun, which is Mercury. It doesn't take that long for it to do that. I think 88 days, which is very short. And the planet with the longest year is the one that's the furthest away from the Sun. That's going to take a really long time to orbit. So that is Neptune. Well done if you got those ones correct. And then the orbit itself. So the planets do not orbit the Sun in a perfect circular motion. Their orbit is elliptical. So if you remember at the beginning, we said we were going to go through what the word elliptical meant. So if this is the Sun in the middle, and here's the Earth, this is not the path that the Earth would take when it orbits the Sun. In fact, it would take this kind of a path. So here's the Sun in the middle, here's the Earth, and the pattern of the orbit is elliptical, like that. Okay, so take a minute and copy down the information in front of you, and then when you're ready, we'll go on to the information on the next slide. Right, now we've spoken about how we have the Sun at the center of our solar system and how we have different planets that orbit the Sun, and we've talked about the shape of the orbit, and we've talked about how a year is how long it takes for the planets to orbit. What we haven't mentioned is some of the other things that are actually part of our solar system. One of those is comets. So there are a number of different comets in our solar system. One of them notably is Halley's Comet, which returns after every 72, 74, 70 something odd years. So every so often we will see Halley's Comet pass the Earth. So comets are actually icy rocks. Okay. So they are icy rocks. So they've got loads of ice on them, which if they were to fall on the Earth and that ice would melt, it would be a source of water. So comets are icy rocks in orbit around the Sun, so they orbit the Sun as well. And as they get closer to the Sun, some of the ice actually does start to melt, and it makes a really large tail behind the comet. So this that you can see here, this tail, which you can see it says here the dust tail, is actually the melted water. Okay. And the tail always points away from the Sun regardless of the direction of the comet. So if the comet is going left to right, the tail was going to go away from the Sun. It doesn't matter which way the comet is going, the tail is always going to go away from the Sun. Now, comets are thought to be leftovers from the formation of the solar system, so you might feel quite sad for a comet. It didn't make it to the planet. Maybe it wanted to become part of a planet, but had to settle and remain a comet. Okay, so comets are thought to be leftovers from the formation of the solar system, and there are quite a few different missions as well that have been planned to send photos, send space probes, so that they can take photos of these comets. And another mission actually is to get a sample from a comet and bring it back to Earth for further study. So I think that would be really cool if scientists were able to do that. And then we've got this absolutely lovely picture, and it shows meteors. Yeah, so I'll write that down at the bottom so you can see it. Meteors like this. Right, now meteors are rocks in space, and as the Earth moves through its orbit around the Sun, so remember we said it takes 365 days, it goes through the areas of space where there are loads and loads of different rocks known as meteors, and some of them are really big and could be as small as a grain of sand, and others are as large as big buildings, so very big difference in size. And what happens, some of these rocks actually enter Earth's atmosphere, and then when they do that, they rub against our atmosphere and they heat up due to friction. So remember, that was one of the forces that we learned about friction. So these rocks go through our atmosphere and they heat up as a result of friction, and that leaves a really nice bright tail that we can see in the night sky. So you might think of it as a shooting star. That's what some people, when they see a meteor go through the Earth's atmosphere, they call it a shooting star, but it is actually a meteor that's going through our atmosphere. If you get up before sunrise in October, I know we've passed October now, you're going to have to wait another 8 months to get there, but if you look towards a specific constellation, Orion, which if you want more information about it, you can email me, you might see a meteor shower, and it peaks at around 1 meteor every 3 minutes. So it's very, very cool if you're able to see it. Obviously, if it's not cloudy and you don't have a lot of clouds in the sky, but if it's a clear night, you should be able to see 1 meteor every 3 minutes or so. And it's between midnight and dawn during the 3rd week of October. Sometimes what happens, these meteors explode in the sky as well, so you get an absolutely beautiful effect of what actually looks like fireworks. And then some of these meteors do actually make it all the way to the ground, which you can pick up. So it's very, very cool to see, and you have had some people that have found meteor rocks. So it's a really cool thing for scientists to be able to study. And then the last thing that we're going to go through of what is part of our solar system is different moons of the solar system. And these different moons, do you remember we said that Jupiter and Saturn and those larger planets that have rings around them, those rings will come together and they will form moons. I've just got a picture of Earth there in the corner just so you can compare the sizes of these different moons. Earth's moon is actually relatively small compared to some of the moons, but it's a lot bigger than some of the other moons. I mean, if you have a look here, here's the moon, Uranus's moon Puck. It's absolutely titchy. And then you've got Titan here, one of Saturn's moon, which is really quite big. Yeah. So you've got a number of different moons, and they range in sizes to the absolutely titchy to the ones that are actually quite big. so that concludes your lesson on the solar system and how it was formed. And I know there was a lot of information there, so really well done for getting to the end of this lesson. What I would like for you to do as your final task is I would like for you to take the information that you got, and I would like for you to produce a concept map. Now I have written a list of keywords which is attached on class charts, and what I'd like for you to do is to use those words and group them together if there is a similar pattern between them. And I'll show you exactly what I mean. I'll start for you. So for example, you can say you have Earth, and Earth is a planet. And you might have many different planets, so I'm going to write Mars, I'm going to write Jupiter, I'm going to write Saturn. I'm going to write the names of all the different planets. How did those planets come about? Those planets came about from large cloud of dust. What else came from a large cloud of dust? That's how we got the sun. And what do I know about the sun? I know that the sun, which gas is inside the sun? Do you remember the name of, it begins with H? What's the name of the reaction that's happening in the sun? Okay, so this is just a very small example of how you can link the words together. So what I would like for you to do is I would like for you to find a way of linking the words together that you see on your worksheet. Okay, don't worry if you can't fit all of the words on there, and don't worry if your concept map looks different to somebody else's. That's exactly what we're looking for. We want to see however many different ways you can of producing a map that links all the different words in your worksheet. If you get stuck, send me or your class teacher an email. It's absolutely no problem. Okay, but let's see what you could come up with. And finally, I just want you to memorize the 8 planets of our solar system. I think you know them already. I'd like for you to start with the one closest to the sun, and hopefully we shall have a live lesson, and I'm going to test you at the beginning of that lesson. It's not going to be a marked test, it's just for a little bit of fun. But thank you very much. I look forward to seeing your work, and any questions, please do email your class teacher. Don't forget to take a very clear picture of your work and submit it on class charts. We will be checking, and I will see you next time. Thank you very much. Bye.